Looking at this worksheet that you guys got, and like I said, this is supposed to represent basically, in my head anyway, this represented a roadmap for this process. So it's like a step-by-step direction for what happens in here, complete with these things that you see right here, which I considered, since the arrows are going towards it, like an on-ramp, things that are coming in and like getting on the freeway. This right here, like an off-ramp, stuff getting off of the freeway right there. So the arrows, what's wrong, Eden? All right. So what I was considering, and you're going to have to work with me here a little bit, but I considered this like the road, right? So this is supposed to be a map of like whatever, I-5 or whatever you know. Whatever you want. So Aiden, the word no means no. So I'm just joking. Yeah. No. So at the very start, this molecule, it's 6 things big, right? What one molecule do we know that kind of starts us off with 6 things big? Right. So what I was picturing here was, here's glucose, and its molecules follow these paths. Along the way, they've got different options, like they can turn off, other things join them and collect stuff from them. So that's what all these arrows represent along here, the different processes that occur. So, like I said, my head probably works different than your head, so we do different things, but in my head, this made sense. So I'm going to work through it with you guys, and I'm willing to bet that we can get to a point where everybody kind of understands what happens here. And then, like I was saying, this is the map, essentially. This is one way to give directions. The other way to give directions is through, like, written directions, as in turn left after the second mailbox, and then do this over here. On the back side of this, you're going to describe these steps that are taking place on here, like how this process works, what they're seeing as they go through. So that's the idea here. So I'll go through this front side of it with you guys so I can address any questions or clear up any issues we're having, and then we'll proceed from there. Annabeth?
So when I was doing like treatment yesterday and looking at the Krebs cycle, what's like the actual component of the Krebs cycle? Is it anything you got?
Yeah, so the Krebs cycle takes energy that's stored in those bonds between these carbons that are here and converts it, in one case, to ATP, but in other cases to those carrier molecules, which are going to take it to the next thing, which is called the electron transport chain. We haven't gone there yet, which is how you get energy. So this is like the... Yeah, it's like an intermediate step, if you want to think about it like that, between like glucose and the final output of ATP. So it's like an in-between step that's necessary. Electron transport chain. Yep. All right, so if we're starting off, anything that's got a label on it like this needs to be labeled. So I'm asking for the name of this 3-carbon compound that we said right there. And we already named it, so we know it goes there. What's the name that goes there? Glucose. Very good. So go ahead and write that in. And then we come down to B and C. So we can do B and C together here at the same time. And B is the input side. So B is the stuff that comes down and before glucose gets split into pyruvic acid or anything like that. B is the stuff that gets added, and C is the stuff that kind of comes out of it. So why don't we start with a name and the number of molecules, which was on your quiz, that it takes to break glucose in half. Very good. So one of the things we can add right there in the input side would be 2 ATP molecules, which is great. When those ATP get used, they turn into this. What's the name of the thing when ATP gives up its energy, turns into ADP. So on the output side by C, we'd have 2 ADP, like that. And I think I talked to you guys about how to remember these, but the way I remember those is that T in the ATP stands for tri, which means 3, right? TRI. And ADP, the D in ADP stands for di, which means 2. And 3 is bigger than 2, which means 3 has energy, tri has energy, and di doesn't. That's how I remember that, because 3... Right, yeah, another way to think about it. So whatever little tricks you can use like that to help you remember stuff helps in this, because there's so many like little kind of not super well-connected pieces of information, because we're leaving out big chunks of chemical processes that take place. So it's just like, this molecule turns into this molecule. So that's one thing. ATP comes in, ADP goes out. 2 other molecules go in there. And that we're looking for. Keelan? Not yet. Not yet. Not yet. No, we're looking for things right here. So we're looking for... Huh? NAD is one that goes in. Do you remember how many, Aiden? Yeah, 2 NAD. So then coming out of it, NAD turns into... And the way I remember that is NAD's got 3 letters in it. NADH has 4. The thing with more letters has more energy. That's the way I keep track of that. So NAD is an empty bucket. NADH is a bucket that's full of energy, ready to get transferred to the next step, which we'll talk about next time, which is the electron transport chain. Final one for B. We're looking for these things that come in and get turned into energy. No. One more time ought to do it, probably. I know. So here, let's do this, because I'm a little frustrated that you keep yelling out answers. Raise your hand, and when I call on you, you can say it. No, that comes a little later on. You're overlooking the big one here that's probably the simplest one, then you're just kind of overlooking it. No, not that one. Logan? Oh, I thought this was a hand raise. Sorry. Not a hand. Go ahead.
Wouldn't it be glucose?
No. So glucose is here. We already got that going in. Hunter? No. So what we're looking for here, and there are 4 of them. 4 ADP come in, right? And they result in 4 ATP. So 4 empty batteries, 4 batteries that have been used of energy comes in, and it gets converted into new batteries again. And ATP is kind of a unique molecule. So it's looking like that. ATP and ADP are pretty similar in that they've got the same structures. One just has 3 phosphates on it, and one has 4 phosphates on it. So this is the ATP, ADP. But one thing about ADP is that always close by to it, there's the 3rd phosphate. So these things, like, you don't have to take ATP vitamins or anything like that, or this stuff is inside of you. You get it in the food that you eat, and it's a recycled molecule. So like when ADP gets turned into ATP, all that happens is a little bit of energy is used to connect this phosphate to that phosphate and make a bond to turn it into this. That energy is stored there. When your body uses that energy, it just breaks this bond. This phosphate doesn't get used up. It doesn't disappear. It just floats off again and looks like that. So it can be totally recycled. When you've got more energy, energy is used to bond that on there. And then when you use it, that bond breaks again. So that's how this ATP, ADP thing works. ADP is when it doesn't have energy and there's a phosphate nearby. And then the energy that's there is used to stick that phosphate on there. That's all it is. First process, part of your quiz today. First step in cell respiration. Glycolysis. Very good. So is the glycolysis process we were talking about there. When glucose gets broken into those 3 carbon molecules, which is what this part of it represents, it has a name. So we're looking for the name of that 3 carbon molecule. Keelan? Nope. Pyruvic acid. So on D, we want the word pyruvic. So D is pyruvic acid, and if you remember, pyruvic acid is just glucose, essentially. Glucose split in half, right? That glucose got broken in half, and as a result, you had 6 things that were glucose, and now you've got 2 things of 3. All right. So pyruvic acid immediately undergoes an oxidation process, and it loses something. What does pyruvic acid lose right off the bat? In the form of what? Very good, carbon dioxide. So each of these, you can see that the road diverges here because we've got one thing going one way, one going another way. This is supposed to be a pyruvic acid, that's supposed to be a pyruvic acid. So on both sides, those 3 carbon molecules lose a carbon dioxide, right? So they lose CO2. So E and F are both going to be CO2. They both lose carbon dioxide. When they lose that, Keelan's been saying this name all afternoon. So Keelan, when pyruvic acid loses a carbon, it becomes this substance. Yeah, what's the first word? Yeah. acetyl. Coenzyme, so short for coenzyme, I'm just writing co, and then a capital A. So that is G and H. Right, so now we're at a, how many carbons big is acetyl coenzyme?
4.
With a hand? 2. So each one of these starts at 6. Here it gets split to 3. A carbon comes off of each of them. So they were 3. If one carbon comes off of each of them, now they're down to 2 apiece, right? Yes, Mr. St. Clair. Raiden.
Can you just scoot the paper over? Now it's on my. Thank you, good sir.
Yep. All right, so we're making progress here down the list then. And you can see on one side here, right, these things both don't enter the process at one time. One goes first, and then it comes back and gets the other, right? So we're going to take one of these. We'll take this one. Maybe we'll put a number 1 right there and say this one's going to go first. And the first thing it does is it bonds with this 4-carbon compound right here, which we'll come back and get in a second, and creates a 6-carbon compound. So this 4-carbon one is always spinning around inside of there. And when it comes up, though, it collects this 2-carbon compound with it, making a 6-carbon compound. This 6-carbon compound has a name that we're looking for. Let's see. We'll get some people we haven't called on yet, because I feel like I keep calling on the same people. Mr. Clark, what's the name of that 6-carbon compound? Very good. Yep, so I, right here, should be citric acid, just like that. Very good. And citric acid is one of the reasons why this cycle has another name. One name for it is the Krebs cycle. The other name for it is the citric acid cycle. So as we work our way down here, one of the keys, hopefully you realize, is that every time carbon dioxide is given off, energy is released. And you can see as soon as this 6-carbon molecule starts to go through the process, it gets oxidized and loses a carbon. So there's its carbon dioxide being given off right there. And as a result of losing a carbon, it also must release energy. So we're looking for the name of the energy carrier molecules that it is. Jackson? All right, so on J we're going to have NAD, and then on K, NAD turns into, Jackson, NADH, like that. And again, that's a little plus sign because technically it's NAD plus. And that's why, remember, NAD, less letters, empty bucket. NADH, more letters, full bucket. Right? Less energy, more energy. Yes, ma'am? Yeah, go ahead. Yep. Very good. So the next one that you've got here, we've got an empty battery, or a discharged battery, ADP coming in. And it is fully charged as it leaves, so ATP. And that's energy your body can use immediately. And since you were at a 6-carbon compound, and when one of those things broke off here, we're down to a how many carbon compound now? 5. We don't have a name for that, and that's fine. I'm not going to make you guys memorize a name for that. Once we're down to a 5-carbon compound that you can see there, oxidation occurs again, and another carbon leaves in the form of carbon dioxide. So that's that CO2 you see leaving. That's a carbon getting ripped off of that 5-carbon molecule, leaving. And then its energy, the energy that is left over from that bond breaking, is collected by these molecules. So we're looking for the name of these molecules that collect. Go ahead and start us off with one. Ooh, what line are we going to put that on? How about that? On O? Very good. NADH. And then what's going to go on N then? NAD plus. NAD plus. There we go. Looking good. So that's one of them. Yep. So there's a bucket of energy. Once that 5th carbon breaks off, energy is released. So one bucket of NADH comes in and gets full of energy. Anthony, what's the next thing we have on there? Good. NAD plus and NADH. Question, Anthony? Okay. Well, let's see. Olivia, can you tell us the last one? Can you tell us the last one? No, we've got 2 of those, and there's one of the weird ones. There we go. Very good. So now we've got that process done. We're back down to a 4-carbon molecule here, right? What happens to this 4-carbon molecule? Hold on. And so this, let me ask that a different way. Does that 4-carbon molecule ever, get released as carbon dioxide? Does it ever leave that cycle? It does not. This is a permanent fixture inside of here. This molecule never gets smaller than 4. All it does is in this process, it's going to swing up and pick that other one up, that other acetyl coenzyme A. And since it was 4, and it's picking up a 2-carbon molecule, it's going to turn into a 6-carbon molecule, and just repeat the process, right? So for every 1 glucose that enters into the Krebs cycle, how many times does the Krebs cycle spin around? 2 times, right? 1 for each half of it. For every molecule of glucose that enters into this process, how many molecules of CO2 are released? You've got the answer to this, so look, don't guess. Nope. Look, don't guess. Nope. But if we can trace this around, you can see those molecules disappear. There's 1 carbon leaving and 2 carbons leaving. There's 3, 4, and then if you remember, this thing goes around a second time, 5, 6. So that whole thing gets breathed out. Every ounce, every molecule of carbon dioxide you breathed out started as glucose. So the stuff you're breathing out right now, seconds ago, was a glucose molecule that your body was using to make energy. Right, Hunter? Somebody want to wake Hunter up? Yeah. I'm glad we got that on video. How many times did I say your name, Hunter? Yeah, that's not a question yet. That was 2, which makes it really clear. Hi, Mr. and Mrs. Humphreys. That's your daughter over there. And in this class, if you ever wanted to see what she was doing, it was sleeping. Right, so when your parents call or whatever, how does our daughter do in your class? I've got a video, and at minute number, whatever this is, 23 minutes, 17 seconds, you can see how your daughter does in my class. Because grades don't tell the whole story. On the backside, how this process works in words. So, what's happening in words? We just came up with, the map directions for this. So here's a map. You could now tell me how to get from, glucose down to this 4-carbon compound here. But what I'd like you to do now is on the backside is tell me in words how to get from there to there. What processes are happening, what things are happening between here and there. T, that's that 4-carbon compound. It's oxaloacylic acid. O, and I'm going to butcher this, Oxaacilic. Huh? Yep. ACID.